which term of the AP is 210? So they have given you this sequence. This sequence has the first term 21. And now the values are going higher, or I see that the difference here is quite big. Let's find the difference. I don't know which term it is, but there is some term which has to be 210. Okay? That is how my sequence will look like. If you look at the difference, what are you adding? There is an addition of 21. Quickly, if I have to tell you to find the common difference, always take the second term and subtract the first term. Or it's not just the second and the first term that will help you find the difference. You can take any term minus the previous term. Okay? In an arithmetic sequence, if you know the back-to-back coming terms, then you can always find the difference. So always take the second one. Always take the later one first and then subtract the previous term of the sequence. That is how you find the common difference. So in this question, the common difference can be obtained by just writing 42 minus 21. And that is how you found that the sequence has the difference 21. So my first term is also 21. My difference is also 21. Question is asking you which term has to be 210. Yeah. So I'll say that there is some term in this sequence which has to be 210. And I know how to generate any term of any sequence is to take the first term and add the difference for one less time. Now the interesting thing here is we don't know which term we are in. Yeah, that is what we are trying to figure out. We want to look which term will be 210. So what you can do, you plug in the value of A, which is 21. You don't know n, so you cannot solve for n minus 1. So times 21 should give me 210. And if you simplify this, it becomes 21 plus 21n minus 21 equals to 210. Before I bring out anything from the left side, I see I have two equal and opposite number. Plus 21 minus 21, you cancel them out. 21n equals 210. You divide both sides by 21. And that is how you find the value of n. For this question, we got the answer that n has to be equal to 10. The 10th term of the sequence or the 10th term of the progression has to be 210. That is how you find the answer. It's very important to note when the question has told you which term as in you're finding the position. So whenever position is missing, that is when you'll keep n as your unknown or you'll solve for n. Okay? You should know that very importantly. It was actually clear in the beginning itself by looking at the numbers. If the first term is 21, the difference is also 21. It means it's just the table of 21. Yeah? If I start from 3 and I'll keep the difference 3 every time, what do I get? I just get the table of 3. So in that case, what happens? 3, 6, 9. If I have to write a general term or general way of expressing all numbers that appear in the table of 3, then what can I do is, the general formula will simply be 3n. Why? Because you can use the formula and see if the formula will help you or not. But the logic is 3 times the position should give me that particular multiple of 3. If I look at the examples of arithmetic sequences, then all you have been studying is just arithmetic sequences, the tables, if you'll take the example of. Yeah, all the tables are example of arithmetic progression because it starts from that number and it continues to go on and it continuously increases by that value.